Quadratic functions. As we begin a series of video lectures on quadratic functions, let's start by discussing their properties. Okay, so specifically for this video lecture, our objective, identify a quadratic function and its vertex, axis of symmetry, and direction of opening. Alrighty, what do we know? Well, in a previous series of video lectures, we talked about quadratic equations. So we know what a quadratic equation is. It's an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a does not equal 0. And if you'll recall, the reason a cannot equal 0 is a quadratic equation requires an x squared term. If you don't have an x squared term, if a is equal to 0, you're dealing with a linear equation, not a quadratic equation. So, just as we saw with linear equations and linear functions, a quadratic function, you're basically taking a quadratic equation, which you could write as y equals ax squared plus bx plus c, and you're going to write it using function notation. So we come up with f of x equals ax squared plus bx plus c. So what we're saying here is the function machine takes whatever's input, whatever's put into the machine, you put x into the function, you're going to square it, multiply that by a, you're going to add that to what you put in times b, and then you're going to add c, and the output, you're going to get an output. You're going to get a member of the range. Okay, so let's talk a little bit about some of the pieces that go along with this, in particular regarding its graph. So the graph of a quadratic function is a parabola. Okay, you probably have seen that word before, perhaps. A parabola looks just like this down here. That's a parabola. It's a curve that opens up or opens down, just like this does. It could be wider, it could be narrower, but it opens up or opens down. And it has a minimum point if it opens up, or a maximum point if it opens down. Its parent function, and we've done some look at our library of functions, our library of parent functions, f of x equals x squared. So the base parabola is f of x equals x squared, the parent parabola, if you will. Okay, a parabola has a vertex. The vertex of the parabola is the maximum, which would be called a high point, or the minimum, which would be called a low point of its graph. Okay, so here's a parabola. This parabola opens up, and so the vertex in this case is a minimum. Because it opens up, the vertex is a low point. And a parabola has what's called an axis of symmetry. Parabolas are symmetrical, and they are symmetrical about their axis of symmetry. So the axis of symmetry of the parabola is the vertical line passing through the vertex, about which the graph is symmetrical. So here's my vertical line passing through the vertex. The right side, if it were to fold over the vertex, maps to the left side, symmetrical about the axis of symmetry. So again, kind of a recap I've been speaking to. This parabola opens up, as you can see. The opening is up here. I just called this quadratic f of x equals ax squared plus bx plus c. There's a generic name. The vertex, in this case, again, is the minimum. It's a low point, but the vertex is here. And the axis of symmetry goes as a vertical line right through the vertex. And the parabola is symmetrical about that vertical line. Okay, let's talk about some things that we can determine from the equation of this function. So I've rewritten the function. f of x equals ax squared plus bx plus c. Okay, so a few things I can determine. The coefficient of the x squared term is a. If a is positive, the parabola opens up. So the vertex is a minimum. So if we go back to this example I have here, this parabola opens up. The vertex is a minimum. Therefore, this a is a positive number. I don't know what it is, but I know it's positive. Okay? Similarly, if a is negative, well, then the parabola is going to open down. And when a parabola opens down, think about it, it looks like this. It opens down, then the vertex is a maximum. It's at the top, and the parabola opens down from the vertex. Okay, so where is that vertex? Well, we can use this equation to determine the vertex. The x-coordinate of the vertex is found by taking b and dividing it by 2a and taking the negative of that. So the opposite, or the negative, of b divided by 2a. And that gives you the x-coordinate of the vertex. If you want to know the y-coordinate of the vertex, take this and put it in the function. And the output is the y-coordinate of the vertex. So the function's value when negative b over 2a, when the x-coordinate is entered into the function, is the y-coordinate of the vertex. And the axis of symmetry is always the vertical line x equals the x-coordinate. Okay, because as you see here, this vertex has an x-coordinate right here, and the axis of symmetry goes through that x-coordinate, and so it's just x equals the x-coordinate. Fairly straightforward as you work with it. Okay, so the axis of symmetry, the vertical line, x equals negative b over 2a. Let's do an example. I think one example should get us started. Okay, I've got this function, f of x equals negative 3x squared plus 6x plus 1. Okay, so I know it's a quadratic because the squared term exists and it's by largest, it's the largest power of x. It's a squared term is the highest power of x, and I have a squared term. Determine whether the parabola opens up or down. Determine the parabola's vertex and the parabola's axis of symmetry. Then, let's make a brief sketch of the parabola using that information. Okay, so open up or down? Okay, so that's our first piece. Well, that is determined. I'll come up to here. The coefficient, oops, let me get a little bit more, let me get a little higher so you can see it. The coefficient of the x squared term, its sign determines whether it opens up or down. Well, in this case, the coefficient is negative 3. A is equal to negative 3. Negative 3 is less than 0. So, this parabola opens down. Okay, parabola opens down. Okay, let's see here. What is the vertex? Well, the x-coordinate is negative b over 2a, and the y-coordinate is f of negative b over 2a. That's the vertex. Okay, so let's do the x-coordinate. X-coordinate is equal to negative b over 2a. Okay, well, let's see here. B is 6, so I have negative, or opposite, 6 divided by 2 times a. Well, a is negative 3, so 2 times negative 3. Okay, well, that looks like it's going to be the opposite of 6 over negative 6, so I have the opposite of 6 over negative 6, and that's going to be just 1. Whoops, my lead just broke. And now I'm running out of lead. Just a second, let's get my pencil back working. Okay, so the x-coordinate of the vertex is 1. Okay, what's the y-coordinate? Well, the y-coordinate is f of, okay, right up here, it's f of the x-coordinate. It's f of negative b over 2a, which means it's f of 1. Let's put 1 in here, which equals negative 3 times 1. I'm going to substitute 1 in for x squared, plus 6 times 1 plus 1. Okay, so I put 1 into the function, and I'll get out the value at 1, which will give me the y-coordinate of the vertex. Let's see, 1 squared is 1 times negative 3 plus 6 is positive 3 plus 1 is 4. Hope I've got that correct. Okay, so the vertex is at 1, 4. Okay, so I know the parabola opens down and the maximum point is at 1, 4. Okay, what is the axis of symmetry? Okay, well, axis of symmetry is the vertical line x equals negative b over 2a. Sorry about that, my lead is not playing nicely at the moment. Okay, it is x equals negative b over 2a, which is simply x equals 1. We already calculated negative b over 2a. X equals 1 is the axis of symmetry. Okay, let's sketch it. And again, I'm not looking for a fancy sketch here. We're just going to draw a coordinate. We're going to draw our xy plane. Okay. Vertex 1, 4. So here is 1. We'll put 1, 4 here. And I'll just label it 1, 4. Okay. Axis of symmetry is 1. X equals 1, excuse me. So I'm going to draw this axis of symmetry. There we have the axis of symmetry. And I know it opens down and it's symmetrical. So I'm going to just do my best. I don't know a whole lot about it at this point, but I know that it is symmetrical. That's not super, but that you get the idea. I know that it is symmetrical about that line. I don't know if it's narrow. I don't know if it's wide. I'm just giving a brief general sketch of it here. Okay, so quadratic functions we're now into. This is your base equation, f of x equals ax squared plus bx plus c. And when you look at the graph of a quadratic, we have a vertex, we have an axis of symmetry, and we can determine from the coefficient of the x squared term, a, whether or not the parabola opens up or opens down.